All right, we've been doing a lot of transformations in the coordinate plane using the computers, and today we're going to do some on paper. And the reason we're going to do them on paper is because there are some things, especially with rotations, that are actually easier to do on paper than they are on the computer. But since ultimately we do have to do them on the computer, we're going to work on the paper and then find a way to sort of take what we've learned here, translate it into the computer experience doing rotations. Specifically, we're going to rotate each of these shapes, and we're going to use our rotations to come up with a coordinate rule, sort of, that explains how to take the original coordinates and change them to create rotations of the shape. Once we've come up with our rules, we're going to then go ahead and actually do some of the rotations using the coordinates and then see how it works out for us. So first thing, we need to make some rotations of each of these shapes. And I want you to use different colors. I'm using 3 random colors that I picked out here so that we can keep them separate. It's especially important when we do, say, this one down here where the 3 might overlap a little bit. So we're going to do a 90 degree, a 180, and a 270. And for our purposes, we're always going to go counterclockwise. So a 90 degree rotation takes this shape here and rotates it into the next quadrant over. So it goes from 3 to 4. This shape here, the 90 degree rotation, would take it from 1 to quadrant 2, and so on. Well, this one's, of course, straddles 2 quadrants, but anyways, always counterclockwise for our purposes. Now, the thing that makes this easier to do on paper than it is on the computer is sometimes it's hard to picture where this is going to end up. But the truth is, if we know that this is going to turn and end up being over here, what we can kind of do is sort of turn the paper instead, and this is what the shape is going to look like once we move it. And you just got to kind of real quick move it back and then remember what you saw. But that's a little tricky. So here's what we'll do instead. I'm going to turn the shape, and I'm going to notice that point Q is 1 unit to the right of the origin. So I'm going to go back, and I'm going to plot point Q 1 unit to the right of the origin, and we'll call that Q prime. Then we're going to move back, and we're going to note that point H is over 5 and down 3 from the origin. So 5 to the right, 3 down. So we're going to turn it back, and we're going to go 5 to the right and 1, 2, 3 down. And this is going to be H prime. And then we'll go back again. And in our turned position, 90 degrees counterclockwise, J is 3 over to the right and 5 down. 3 over, 5 down. So we turn it back. And we're going to go 3 spaces over, 5 spaces down. And this is going to be J prime. And then, the best we can, if you want to use a ruler, but I think it's really necessary for this, our 90 degree translation looks like that. We turn it back. There it was. And there it is. Now, to do the 180 degree translation, it's just another move over. So we just do the same, another 90 degree rotation. If we remember what our 3 positions were, they were, I turn it back, over here it was over 1. So when we go over this way, we are over 1 space. These 2 colors kind of look the same. All right, going back, it was over 5, down 3. turn it, over 5, down 3, and then going back, we had over 3, down 5. Go back over here, over 3, down 5. Here is our new shape over here, and we have Q, call that Q double prime, H double prime, and J double prime. Now we have to do it one more time. Over one space. So when we turn it, we're over one space. And if you remember, turn it back, was over 5, down 3. So it's over 5, down 1, 2, 3. And then the J was over 3, down 5, over 3, down 5. We'll connect them. And we'll call this Q. This we'll call it triple prime. This was H, triple prime, and this is J, triple prime. So going back to the original here. So there is our 90-degree rotation, our 180-degree rotation, and then our 270-degree rotation with all of our rotations going clockwise.